All right, we're gonna get it, I promise you. I call this level 1 because we're gonna leverage the beauty and symmetry of a square, just like we've done before when we were solving quadratics. So let me get this rolling here. All right. Well, let's just get started right away. I'm gonna show you 2 methods. There are more methods, but these are the 2 methods that I've kind of settled on, that I teach more often. The other one is the split the middle, and I'll put some other videos up about that as well. All right, so let's go 2 methods. Factoring. Factoring is the creation of multiplication. So first one I'll show you here is the area model. Dun, 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 dun. You wonderful area model. So what we'll do is I just dropped my marker. Oh my God, I'm in too much of a hurry. Gotta slow down. Gotta let that groove happen. I'm telling you, that's what you gotta do. All right, so what we'll do is we'll set up our area model. Wonderful. So the first thing we're gonna do is leverage what we know about multiplying. So a lot of factoring, the way we're going to approach it is we're going to get really good at multiplying. That's why I like these techniques, because they reassert our skill set. So what we'll do is we'll put the n squared here, and the plus 25 will go right there. Now the middle term is going to be this one plus that. So I don't actually know when I approach these problems what's going to go there and there. Now, if you notice this is a perfect square trinomial right away, well, you could put 5 and 5. But right now, I'm just going to say, well, I'm not totally sure what goes in those 2 orange boxes, but what I do know is that if I add these 2 orange boxes up, when you add those 2 orange boxes up, I should get 10n. That is very beautiful, Mr. Miller. That is very, very beautiful. Oh my God. Okay, so first what we'll do is we'll get the n squared. So it's this dimension times this dimension. So it could be n times n, most likely every time. Possibly could be n squared times 1, things like that. But you know, we're going to look at that as a square. Go n times n. Back here, perfect square. So I think let's go 5 times 5. If we've practiced our perfect square trinomials, we'll kind of notice the relationship between these 3 terms. So now let's figure out what this one is. N times 5, 5n. 5 times n is 5n. Perfect, beautiful. So you can see if you were to add those 2 terms up, we would get the value we're interested in. And so, voila, that means that the answer is going to be n plus 5 times n plus 5. Now, when we have the same term twice, let's take advantage of exponents and say it's n plus 5 squared. Get out our trusty green marker. Oh my God. Unbelievable, unbelievable. You can't beat that. You know you can't beat that. And there we go. So kind of remember, when you go from here to here, that's called factoring. And when you go from there to there, that's called multiplying. And so when we factor, I also want you to be improving your ability to multiply. So keep that in mind. All right, we got multiple goals. See, that's why you're gonna put the music back on, and the music stopped. What the heck? There we go. That's a whole different song. All right. So I'm gonna do the same problem, but just a different way. So this is what I would call like the reverse FOIL method. Like if that's what you're calling it. I'm just going to call it the reverse distribute. So let's see what this method looks like. So let's go back to n squared plus 10n plus 25. Act like we don't know the answer, all right? Let's use our imaginations like we ain't know the answer, even though we know the answer. Let's act like we don't. In a lot of advanced mathematics, you actually do something similar to what we're going to do here, which is that you predict the structure of the answer. And so we're just going to predict, because we know we're factoring, that the answer is going to have this feel to it. And you can put a plus sign here if you want. You can set up plus signs. Okay, so let's look at this. Let's try to make this all work together. So first thing that I would do is just make sure that the two edges are spot on, that they're cash money. So that's n, that's n. That gets you your n squared. 5 times 5, that's going to get you your 25. And we can check it just to make sure, right? So we want to make sure, okay, are we square there? We are. Literally a square. 5 times 5 is 25. So the only part we need now is we need the 10n. So just make sure it's there. So you know that's this distribute. N times 5 is the 5 times n. And you do that again from that term to that term. And when you add them up, we get 10n. And so we're done. And the answer is what we already kind of knew it was, which is n plus 5 times n plus 5, which is n plus 5 squared. All right, so those are our two methods. What we're doing is we are leveraging the fact, and I'm going to take my hat off for this point, and my jacket. We are leveraging the fact that we know it's a square, or at least predicting it's a square, because the two edges are perfect squares. And so that's really, really nice. So right here we know we're going to go 5 times 5, and here we know we're going to go n times n. And assuming the middle checks in, then we're cash money. All right, well, I got a better eraser than this one. All right, let's go get it, people. Come on, we ain't done yet. All right, last example. Notice this one's got a minus sign. We're not going to worry about it. So if I look at a problem like this, and I'm going to do the reverse... do the reverse distribute method first. So what I'm going to do, let's get the square in there. Is I'm going to predict the structure of the answer. Okay, I'm going to predict, and I'm going to leave the plus sign up there for now. Okay, so I'm going to come here, and I'm going to say, okay, I want to get that x squared, because that's a perfect square. And 49 is also a perfect square, so let's set that up right away. Let's get the x and the x. Let's get the 7 and the 7. Now here's the thing. You know, with the square, you can do -7 times -7 to get positive 49, or you can do +7 times +7. And so because that's a minus, and we're so good at multiplying now that we realize that we're going to have to add to get to the middle term, I can't have two positives. Because where's the negative going to come from if these are both positive? I don't know either. So they're going to have to be negative. So let's get -7s. And I'm going to put the plus sign because, you know, plus minus is to subtract, a plus a negative. And now let's check. We're feeling pretty confident, but let's check. Let's go there to there. Boom! Holla back. Let's go there to there. -7 times -7 is 49. Oh, I'm liking that. I am liking that. And now let's hit the edges. Let's do the other terms, because remember, it's a double distribute. Each term, when you're multiplying, have to be distributed twice. And so what we do, and if you were to add these two, you get -14, which is what we wanted. And so this is the answer. So the answer there is going to be x minus 7 times x take away 7, which is x take away 7 squared. Oh my God, people, that's nice, right? You know that's nice. Oh my God, my green marker. It's got one more thing left to circle because I want to show you this using the area method. So let's hit up the area method, all right? Is that all right with you? Actually, I know what you're probably thinking too. You're thinking to yourself, Mr. Miller, you need a haircut, dog. I know, I do. I'm dying over here. That's half the reason I started with a hat. All right, so here we go. Let's do this area method and knock this thing out. Oh, come on, purple marker. You could be better than that. Come on, purple. You know I need you. All right, so this is the area method. So now we're going to use our imagination. We're going to act like we don't know the answer is right there. All right? And we're just investigating a different method. Again, taking advantage of what we know about multiplication, because when we do the area method, we know the first term is here and that the last term is there. Now, as far as these two, when they're these level 1 perfect squares, they're going to be the same, and you'll figure out your own patterns here. But in general, we don't know what goes there. We just know what it has to add up to. We know that if we add these two up, it has got to be minus 14x. It has to be the middle term. And so what you do is you say, okay, well, let me first get what I know. Let me get what I know. Let me go get that x squared. Let me get the 49. And again, you could do it as positive 7 and positive 7. But as we know, that would mean that this would be positive, and you would get a positive 14. Well, that wouldn't work, so let's make it minus. There's a certain playfulness to factoring. That's how I see. So like my number one, the strategy for you is don't rush. Don't rush. Enjoy the process. I mean, because it's kind of abstract, so you want to make sure you enjoy the process. So worked out, it's beautiful. So I've modeled this trinomial as a square, and so the answer is the dimensions of the square, which is x minus 7 squared. And let's give that green marker one more. Oh, that's the better green marker. All right. Last thing. What's the last thing this marker should write before I throw it in the garbage? Let's go with you are beautiful. Thank you, green marker. You're beautiful too. I do appreciate you. Thank you for helping us out. Buckets.